Hello, everybody, and welcome back to Creation Myths. I'm going to have a shorter one for you this week. We're going to do this one pretty quick. So this one is a little bit improvised. I had something lined up for tonight, and then scheduling conflicts come up, and that happens. So we're going to push the wrong answers only that I originally had scheduled. We're going to get that on the schedule for down the road. And we're going to continue tonight instead the Discovery Institute junk DNA saga, because when I woke up this morning, imagine that right there in my podcast feed on the Discovery Institute ID the Future podcast was a podcast episode featuring Dr. Jonathan McClatchy and Dr. Casey Luskin talking about Dr. Luskin's debate with me on junk DNA. So basically to this point, since that debate, which was a little over a month ago, 5-6 weeks ago, Discovery Institute has published at least 4, maybe more articles on their Evolution News blog, and now a podcast episode, follow up for that debate. So I'm just going to briefly go through a little bit of this podcast episode. I'm only going to go through a little bit because most of what they say, in fact, pretty much everything that they say in this podcast episode, I addressed in my longer video last week. So it's already been covered. This video that we're doing right now is in the same playlist as all the other Discovery Institute junk DNA videos. So you could just go to the prior video in the playlist if you want, and you will find that longer video that addresses some of the things we're going to talk about here in more detail, plus addresses a whole bunch of stuff that we're not going to cover here because you know what? I covered it there. I don't need to repeat myself. So the way this is going to go down is we are going to play just a little bit of this podcast. Total, it's like maybe 4 or 5 minutes of it. And we're going to point out some of the problems here with the stuff that Discovery Institute is bringing up. Now, this is going to be highly improvised for me. I've got my notes right here on paper in front of me. So let's go through this. Folks in the chat, just let me know if the sound is okay. I never quite trust it, but I think I did test it, and I think the video is playing okay, but let me know if there's a problem with the sound. There's no video because it's a podcast episode, so it's just a logo, but you will hear Drs. Luskin and McClatchy. So here we go. Let's talk about this podcast.
Well, first of all, let me say Dr. Dan is a very smart guy, and I was very impressed with his cordiality and civility during the debate. I really appreciated him willing to have the conversation, and he's clearly very knowledgeable about this subject. But
right. I'm nice. Creationists, if you're watching this, I'm nice. Come and talk to me. Most of you don't want to. I'm nice. Come and talk to me if I invite you to talk to me.
Dr. Dan's basically his main argument in his opening statement is that, yes, the vast majority of the genome is being transcribed, but he said that it's being transcribed at a very, very low level. And he quoted a paper from 2014 by Kellis et al., which said that, quote, while RNA transcripts of some kind can be detected from 75% of the genome, that nonetheless, quote, a significant portion of these are of low abundance.
Now, I want to be clear before we go any further. That was not what I would call my main argument. That was one of the arguments I made. I would say there was a different argument that is really my main argument that we'll get to in a little bit. But that was certainly one of the arguments that I made, that the level of transcription for most transcriptional activity in the human genome is exceptionally low. And therefore, those RNA molecules are probably not functional. Let's see how Dr. Luskin continues to talk about this.
It goes on to say, quote, for polyadenylated RNA, where it is possible to estimate abundance levels, 70% of the documented coverage is below approximately 1 transcript per cell. And so what Dr. Dan argued, I believe these were about his exact words. He said it is absolutely impossible that if you have RNA, basically segments of our genome that are being transcribed at a level of less than 1 transcript per cell, that it is absolutely impossible that could be functional, that it is basically what he would call transcriptional noise, or what I would say he's gone from junk DNA to junk RNA, saying that, all this RNA that's being produced is just useless junk RNA that's not being transcribed for any reason. and that such a low degree of transcription is, he would say, is impossible for it to have function.
I think a better way to describe my argument is that an extremely low level of transcription paired with the lack of purifying selection operating on that sequence is strongly indicative of non-function. I think would be a better, more accurate description of my argument, but let's continue.
And what did you say in response to the citation of that paper by Kellis et al.?
By the way, that's Dr. McClatchy, who is kind of hosting this episode. So it's McClatchy interviewing Luskin about the debate.
Sure. So thankfully, Jonathan, we were prepared for this argument. We dug into the literature quite a bit, and we found what the literature actually says. First of all, you have to understand, it's a very strange statistic for this paper to be saying that there is below 1 transcript per cell. How could you have below 1 transcript per cell? That's kind of like when, people say that if you want to keep the population at current levels, you have to have at least 2.1 children per couple, right? So you can't have 2.1 children. How can you have below 1 transcript per cell on average? Well, that's because it's an average, right? So if you think about this as an average, it makes perfect sense what's going on. You could have, for example, a situation where in 145,
hang on, I just want to pause there because the way he phrased that is really important. He said, you could have, and he's going to go on to make this argument that could be the case, right? You could have the situation that he's about to describe. And I'm going to go back to make sure that we don't miss anything here.
Perfect sense what's going on. You could have, for example, a situation where in 145 of the 147 cell types that ENCODE is studying, maybe that particular genetic element is not being used. So there's 0 transcripts being produced. But then say in 2 of the cell types, maybe it is highly active and it's being used for some important function. Maybe in each of those 2 cell types, it produces, say, 50 transcripts per copy. Well, now I've got a situation where there are 100 transcripts being produced that have been detected by ENCODE and 147 cell types. Well, guess what? That is an average of below 1 transcript per cell. And that's because, as we said earlier, the vast majority of our genome may only be active in certain cell types, in certain parts of the human life cycle. And so it's not actually being used most of the time. That doesn't mean it's not important. That doesn't mean it doesn't have an important function in those rare situations where it is activated and being used. So that is why on average, you might get a very low copy number, but that doesn't mean that in certain cell types, that particular genetic element is not highly active and is not being used. And of course, as we mentioned earlier, ENCODE hasn't even studied many of the cell types yet, so there's still a lot more to be discovered. But there's another important point, and this is all.
Okay, let's pause there because this is the thing they've been leaning on since the debate. They've made that point in several articles, plus in this podcast since the debate. So here's the argument, right? The argument is that, well, they're not studying every cell type. They're studying a lot of these cell types, though, and maybe it's being expressed at a high level in 1 or 2 of them, and then basically 0 in all the rest. So you get a very low average. But there are certain cell types where it's still being expressed at a high enough level that it could be doing some important function. Now, you'll notice, I think everybody noticed there, that Dr. Luskin said this could be the case, but he didn't provide any data to that effect. And in our debate, sorry, I'm losing my voice here. In our debate, I pointed that out. I pointed out that he's making an assertion without the data to back it up. The Kellis paper that he cites does not provide data to that effect. So what are we doing here? Well, they continue to make this argument since the debate. So I actually went and looked at these data from the paper that Kellis cite. It's from another paper from 2012. And the data are this. And I went into this in detail in my previous video on this topic. I'll just restate it very briefly right now. For the regions of the genome that were studied, the abundance of the transcripts, they looked at retrotransposons, and I think also endogenous retroviruses, and combined these categories, signs, lines, LTR retrotransposons, and endogenous retroviruses, make up 1.5 to 2 million individual elements in the genome and collectively cover about 50% of the human genome. And if you go back into the data that Kellis cite in terms of these low average levels of transcription, the paper they cite actually provide the assay by assay data. And if you're extraordinarily generous in your assumptions, you set a really low threshold for what would constitute like that, well, it's high enough in some cell types that Dr. Luskin refers to. If you're really, really unrealistically generous in your assumptions, you arrive at a number of approximately 0.23% of those 1.5 to 2 million elements are being expressed in at least one cell type at a high enough level. 0.23%. Now, again, Dr. Luskin, Dr. McClatchy haven't cited any of this data at any point to date, but I did in my previous video, and I'm summarizing it here just so everybody is on the same page. So now I'm going to jump ahead a little bit because they say, okay, that's one argument. Then there's another argument that Dan made, and we're just gonna briefly hear a little bit from that section, and then we're gonna wrap this up because, like I said, we're gonna keep this short. And I addressed all this stuff in my previous video, but there's a couple small things I want to point out here. So let's just hop ahead to about 1740. Yeah, that'll do. We'll start there. Okay, here we go.
Is coming from non-coding DNA make it impossible, absolutely impossible, he said, that it could have function. And after I responded to that, he never raised that argument again. After we showed that this was an average, that you could have some cell types where it's expressed at low levels, but others at high levels. But even if it is expressed at low levels, that in no way precludes it having functions. He never raised this argument again. So I felt like we kind of did a good job of, I would say, basically refuting his A argument. And then the rest of the debate.
Okay. I never raised that argument again during the debate because he didn't cite any data. He said, this might be the thing that's happening. I said, okay, the paper doesn't say that. There's no data in the paper that says that's the case. You're not citing any data that's saying that. And I moved on because if you say something could be the case, but don't provide any data saying, like, supporting that that's actually the reality, then I don't feel obligated to spend more time on it. Now, really interesting thing is they have repeatedly said that this is my main argument. This transcript abundance thing is my main argument. And I don't feel that that's the case. I feel like there's another argument I made that's my main argument. And the way you know it's my main argument is I spent most of the time during the debate talking about this other thing. So they're going to just mention this briefly right here, and then I'll talk a little bit. So let's hear a little bit more here.
He kind of fell back to another argument.
And what was the other argument?
So that other argument was that there are certain repetitive elements in our genome called transposable elements. And he focused specifically on line elements, which stands for long interspersed nuclear elements. And these line elements, under certain situations, they are able to produce basically proteins and transcripts, which are then translated into proteins, which allow them to then retro-transpose into new locations in the genome. And this allows them, according to what some biologists think, to basically hop around the genome and insert themselves. And some people would say that's why we have many copies of these in our genome.
Yeah, that's why we have copies of those in our genome. There are some that are still transcriptionally active and actually do the retrotransposon activity. There aren't that many, but there are still some mobile ones, and we can see differences in the numbers of them in different people because they are still active in terms of their retrotransposon activity. So it's not a thing some people say, we can directly observe that.
Well, Dr. Dan said that in some cases, or in fact, in many cases, you look at these line elements and they are so quote unquote degraded, that's what he called them, degraded, that they can no longer produce transcripts so that they can then produce the proteins that are needed for them to be able to retrotranspose into new locations in the genome. Okay.
It's virtually all of them are unable to do that because they have deletions and mutations, so they don't have the retrotransposon activity anymore. That's not really up for debate. That's virtually all of them are unable to do that activity because they're missing the enzymes that they would need to do it. Now, they describe this as my fallback argument, and they go on to talk about how it's weird how he spent all this time on his fallback argument, kind of abandoned his primary argument. The thing is, one, the thing that they're kind of talking about is really my main argument here, but also they're mischaracterizing it. It's not about lines or signs or short interspersed. or other, endogenous retroviruses. It's not about them having or not having, like for lines, for example, having the enzymes to do the retro transposing activity. That's not my argument. My argument is that the vast majority of the genome is not experiencing purifying selection, meaning it's not constrained at the sequence level. And that's true for virtually all of these retrotransposon and endogenous retroviral elements in the genome. This just means that they're able to mutate freely. That could be single base substitutions, it could be deletions, and there's no cost to these mutations. And if that's the case, then it's likely they're not doing anything, because whatever it is that they do in the genome, it's not dependent on them having a specific nucleotide sequence. And I want to be clear, this thing about constraint in the genome is, if you're going to say, like, this is Dr. Dan's main argument, like, this is it. This is not like a fallback argument. And they kind of like muse about this, like, he spent all this time on this fallback argument. Gentlemen, this is like the main thing. This is the big thing you need to address. And it wasn't just specifically about lines, and they're off base on what my specific argument is here. It's not about, lines are unable to do this specific activity, which is true, right? It's about they're not constrained, meaning they're not doing any specific activity that requires a specific sequence. We know that's the case because the sequence can change, including experiencing deletions with zero cost to the organism, right? That's the argument. So if you're going to say that these regions are functional, these regions that make up the vast majority of the human genome, if you're going to say that they are actually functional, then you have an obligation to do two things. You have to, one, propose the sequence-independent functions that they're doing, and two, you have to provide evidence that they are doing those specific functions. And I asked that question during the debate, didn't get an answer. I've asked other people this question at various points in the past, haven't gotten an answer. I've kind of thrown this back out there to Discovery Institute since the debate. Haven't gotten an answer to this question. So let me play for you now the part in this podcast where they address this actual argument, the idea that the genome is 92% unconstrained, right? 92% of the genome does not experience purifying selection. Let me play you the part where they talk about what that part of the genome is probably doing. It's right. Oh, they still don't do it. They're still strenuously ignoring the main argument I've been making. What's the answer, Discovery Institute? 92% of the genome can experience mutations with zero cost, including significant deletions. If these regions of the genome are functional, what functions are they doing? I asked Dr. Luskin during the debate, and he provided a number of answers that require sequence specificity. In here, they talk about transcripts that could have function at very low frequency. One of them that Dr. Luskin mentioned is a protein coding gene, which is kind of funny. But they don't even attempt to answer the question of what could these things be doing that are sequence independent. So that's where I'm going to leave this right here. Discovery Institute, Dr. Luskin, Dr. McClatchy, you're claiming that the vast majority of these sequences do actually have a function. Almost all of them are not experiencing purifying selection. So what function do they have that does not require sequence specificity? That's where I'm going to leave this. Thank you all for watching, everybody. I appreciate you all being here. I know as we're doing this live, there's another big event going on over at Guts at Gibbons channel. We're doing a big fundraiser over there. I'm going to go back over there once we're off the air here. So thank you all for being here. I appreciate it. Before you go, please remember to hit the like button, subscribe, leave a comment, share this channel, ping Discovery Institute, tell them to answer this question that they refuse to answer. And as always, don't get fooled. Thank you all. Have a great night.